So how do I solve? Let us solve this equation. First of all, this is not quadratic, but it is something what we call a reducible to quadratic. This is the reducible to quadratic. To quadratic equation. Why? Because I can think of this power here as the double of the power here. This power 4, this power is 2. 4 double of 2, right?
Yes.
And if I have this equation like y squared minus 26y plus 25 equal to 0, this power also is double the power because the power here is 1, right?
Yes.
So this one is similar to this one, right? So we'll make this small assumption. We'll make this assumption. We'll assume here, okay, assume that x squared equal to y. This x squared become y. Small assumption. Okay? And once we make this small assumption, we understand also that, of course, also that means x power 4 equal to y squared. Came from where this? It came from when you square this and square this, you get this and this, right? You square these two sides, you get these two sides. Why am I doing this? Because I want to replace every x squared with y using this formula, and every x power 4 with y squared using this formula. So I made replacements. You understand what's happening? Okay, again. Sometimes you still have to do the substitution. If I give you another example like this, 4p plus 4 squared equal 2 times 4p plus 4 plus 35. Okay? Now, yes, you can open the brackets here and bring everything in one side on the left side, but it will take, longer time, it will be more complicated. It's easier to make this assumption I told you about. If you just make x equal 4p plus 4, this equation will be x squared equal to 2x plus 35, which is much easier to solve than this big complicated one. So the assumption, because you notice here, there's a bracket square, and in the same bracket is multiplied by 2. So you have it one time square and one time without the square. So that, again, should tell you that, well, this is reducible. So this is reducible to quadratic equation. This is reducible to quadratic equation. So that's why if you just make this assumption, life will be much easier. So it's important sometimes to notice the pattern that's repeating. This is the repeating here. One time with a square, one time without square, and then you have a constant. This looks like a quadratic equation. It's not exactly quadratic, but it looks like a quadratic equation. These are famous questions in the exams. So if you notice this pattern, then you can just replace x with this pattern and then solve this simple equation, and then you go back. After that, you go back to the p. So solve for x, and then you go back to the p. Let us do that. This is very easy equation. Just bring everything in one side. X squared minus 2x minus 35 equal to 0. And find two numbers and you multiply them, you get minus 35. They are x minus 7 and x plus 5. The two numbers are minus 7 and 5. And from here, it's very easy. The question now, x equal to 7. I'll just do it quickly. Or x equal minus 5. Now take this back to the p. Which means the 4p plus 4 equal to 7, or the 4p plus 4 equal to minus 5. Okay, and from here I can solve for b, and here it's obviously that 4p equal to 3, isn't it? And here that's the 4p equal to minus 9. If you simplify this more, then you divide by 4 here, so you get the 3 over 4. And you divide by 4 here also, you get minus 9 over 4. So I got the two answers quickly compared to if you open the brackets. So it's good to learn the substitution method in the case of you have a reducible equation to quadratic equation. I have this equation, x power 4 minus 26x squared plus 25 equal to 0. Assume that x square equal to y. خلاص? Now square both sides. If you square this, what do you get?
X4.
X power 4. So that means x power 4. But if you square this side, what do you get?
Y squared.
Y squared. So that means if you assume this, automatically this is also true. If you assume this is automatically true, right?
Yeah.
So what is the benefit? The benefit from this assumption, I will replace the x with y. See this x power 4? I replace it with y squared. So I'm going to write y squared. My equation become like this. And then minus 26. Do you see this x squared?
Y.
I replace it with y. So this will become automatically y. And then I have 25 still. What is the benefit? I reduce the power. I reduce the power of the problem from power 4 and 2 to power 2 and 1. And this is now a normal quadratic equation that you should be used to and you should be able to solve. So I'm going to solve the one for y. Forget about the x now. I just solved the one for y. So let's solve this one. You can solve it by formula or by factoring. But I can factor easily, yes. Let's just factor this. It's easy. Y here, y here, minus 25 and minus 1. So that means y is equal to 25 and that means y equal to 1. Clear now? See what I did? You understand where it come from? This come from originally equals 0 if you want the details. Some people, get lost if I don't do all the details. Okay, this 0. This is all this or this. One of them is equal to 0, and that means y is equal to 25 or y equal to 1. Now let's go back to the x. What was y anyway, if you remember? What was y? Y was x squared. So let us put y equal to x squared here. This is actually x squared. And this is actually x squared. Yes. So if you solve this one equation now, x squared 25, that means x is plus or minus 5. And that means x is plus or minus 1. So how many solutions now we have? 4 solutions. We have plus 5, minus 5, plus 1, and minus 1. Okay, so you can write now the solution set at the end like this. Solution set, okay, for all these possible solutions is 5 and minus 5 and 1 and minus 1. Another way is from the beginning you can just factor using the x as it is. So if you want to do that also, that's also possible. Here, I can just come here and factor with the power 4. Okay, if you want, that's another option. Okay, so from the beginning you say, okay, that's x squared minus 25, and that's x squared minus 1 equal to 0. And then you say, okay, that means x squared minus 25 equals 0, or x squared minus 1 equal to 0. So that means x squared is 25, which means x is plus or minus 5. And that means x squared equal to 1, which means x is plus or minus 1. So yes, you can do the same thing from the beginning. But the idea of substitution is very useful because some other questions will be very, useful to do the substitution. It will be much easier to do the substitution. And we'll see this when we review the final exams.